The National Electrical Code, or NEC, sets specific requirements for the maximum length of unfused conductors in residential buildings. This requirement is primarily concerned with safety and preventing fire hazards. An unfused conductor is a wire that is not protected by an overcurrent device, such as a circuit breaker or fuse, at its point of supply. The maximum length for an unfused conductor in a residence is 50 feet. This rule is outlined in NEC section 240.21. This section covers the overcurrent protection requirements for feeder taps and branch circuit taps. A tap conductor is a conductor that is connected to a feeder or branch circuit conductor between the overcurrent protection device and the load. The 50-foot tap rule allows for a tap conductor to be up to 50 feet long without overcurrent protection at the tap point under certain conditions. There are specific conditions that must be met to use the 50-foot tap rule. Firstly, the tap conductor's ampacity must be at least 1/3 of the overcurrent protection device protecting the feeder or branch circuit. Ampacity refers to the current carrying capacity of a conductor in amps. For example, if the overcurrent protection device is a 100 amp circuit breaker, the tap conductor must have an ampacity of at least 33.3 amps. Secondly, the tap conductor must terminate in a single overcurrent protection device that will protect the tap conductor's ampacity. This means that at the end of the tap conductor, there must be a circuit breaker or a fuse that is sized appropriately to protect the wire from overload. Thirdly, the tap conductor must be installed in a raceway or be otherwise protected from physical damage. A raceway is an enclosed channel designed to hold wires or cables. Examples of raceways include conduit, electrical metallic tubing or EMT, and cable trays. If a raceway is not used, a tap conductor must be protected by other means, such as being installed in a concealed location or using a cable assembly that is designed to be resistant to physical damage. The purpose of the 50-foot tap rule is to allow for flexibility in the placement of electrical equipment while still providing adequate protection against overcurrents. Without the tap rule, it would be necessary to install an overcurrent protection device at the point where the tap conductor connects to the feeder or branch circuit. This could be impractical in some situations, such as when the equipment is located far away from the main electrical panel. The 50-foot limit is based on the assumption that a short circuit or ground fault on the tap conductor will draw enough current to trip the overcurrent protection device on the feeder or branch circuit, even if the tap conductor is not protected by its own overcurrent device. The length limitation helps to ensure that the impedance, which is the total opposition to current flow in an alternating current circuit, of the tap conductor is low enough to allow for sufficient fault current to flow. Exceeding the 50-foot limit without proper overcurrent protection can create a significant fire hazard. If a fault occurs on an unprotected conductor that is longer than 50 feet, the conductor could overheat and potentially ignite nearby combustible materials before the main overcurrent protection device trips. The main overcurrent protection device might not trip quickly enough because the longer conductor has a high impedance, which limits the fault current. It's crucial to understand the implications of using unfused conductors and the conditions under which they are permitted. Firstly, consider the ampacity of the conductors involved. The ampacity of the unfused conductor must be sufficient for the load it will carry and must meet the requirements outlined in the NEC. Secondly, ensure that the termination point has proper overcurrent protection. The overcurrent protection device at the end of the unfused conductor must be sized appropriately to protect the conductor from overload and short circuits. Thirdly, physical protection is essential. The unfused conductor should be installed in a raceway or otherwise protected from physical damage to prevent insulation breakdown and potential short circuits. The NEC provides specific tables and guidelines for determining the appropriate conductor size and overcurrent protection for various applications. It is essential to consult these resources and follow the manufacturer's instructions for all electrical equipment. Understanding conductor properties is crucial. Conductors have resistance, which is the opposition to the flow of electric current. The resistance of a conductor depends on its material, length, and cross-sectional area. Longer conductors have higher resistance, which can lead to voltage drop and reduced efficiency. Voltage drop is the decrease in voltage along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. To minimize voltage drop, it is important to use conductors that are large enough for the load they will carry and to keep conductor lengths as short as possible. The type of insulation used on a conductor also affects its opacity. Different types of insulation are rated for different temperature ranges. Conductors with higher temperature ratings can carry more current without overheating. The NEC specifies the allowable ampacities for various types of conductors based on their insulation type and installation conditions. Proper grounding is another critical aspect of electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip the overcurrent protection device quickly in the event of a ground fault. The grounding system must be properly installed and maintained to ensure its effectiveness. The NEC specifies the requirements for grounding electrodes, grounding conductors, and bonding. Bonding is the process of connecting all metal parts of an electrical system together to create a common ground potential. This helps to prevent shock hazards by ensuring that there are no voltage differences between metal parts. Regular inspections and maintenance are essential for ensuring the continued safety of an electrical system. Inspections should be performed by a qualified electrician who can identify potential hazards and recommend corrective actions. Maintenance should include checking for loose connections, damaged wiring, and other signs of wear and tear. Over time, connections can loosen due to vibration or thermal expansion and contraction. These connections can cause overheating and arcing, which can lead to fires. Damaged wiring can also create a shock hazard or fire hazard. It is important to repair or replace any damaged wiring promptly. When working with electricity, it is important to follow all safety precautions. Always turn off the power at the circuit breaker before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. Never work on electrical equipment while standing in water or on a wet surface. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Working with electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others. Furthermore, consider the specific requirements of the local jurisdiction. Local codes may have additional requirements or restrictions that are not covered in the NEC. It is important to check with the local building department or electrical inspector to ensure that your electrical work complies with all applicable codes. In summary, the 50-foot tap rule provides a limited exception to the general requirement for overcurrent protection at the point of supply. The rule is intended to provide flexibility in the placement of electrical equipment, but it is important to understand the conditions under which the rule applies and to follow all applicable safety precautions. Improper use of the 50-foot tap rule can create a significant fire hazard. Firstly, make sure the conductor is rated for the ampacity. Secondly, make sure that the proper overcurrent protection is installed. Thirdly, make sure the conductor is protected from physical damage. It is essential to consult the NEC and other relevant standards to ensure that your electrical work is safe and compliant. Understanding the NEC requirements for unfused conductors is crucial for ensuring electrical safety in residential buildings. The 50-foot rule, along with its associated conditions, is designed to minimize fire hazards and protect occupants from electrical shock. Firstly, it is imperative to adhere to the conductor ampacity requirement. Secondly, appropriate overcurrent protection at the termination point is a must. Thirdly, ensuring physical protection of the conductor is non-negotiable. Finally, awareness of local jurisdiction rules cannot be overstated. The length limitation helps to ensure that the impedance of the tap conductor is low enough to allow for sufficient fault current to flow.